Okay, so this video is just a quick refresher in binary and denary. So denary we're all familiar with. It's our usual way of counting. We are used to the idea that 156 is 156. If we try to think about when we were first learning numbers in primary school, we started to learn about the place values. So this number is 1 100s, it's 5 10s, and it's 6 1s. When we add all those up together, we would get 156. So we're used to that. We know how it works. It kind of makes sense to us. What we're going to look at, though, is how we do things in binary. Binary still has place values, but they go up. We double each time. So we start off at 1. Our next is 2, 4, 8, 16, and so on. So when we're representing numbers in binary, we would do something like this. So that's 101. It's not 101, we actually just call out the digits themselves. So to work out what this would be in denary, we just look at the place values and then we add them up. So we've got 1 4 and 1 1, so that would be 4 plus 1. That gives us the denary number 5. If I was going to change it around a little bit more, so let's do this. Okay, so this number, we've got an 8, and we're going to add a 4 to that, which gives us 12. And so long as we can remember the place values, and if we decide to go bigger again on the numbers, any number that we do is just a simple case of adding together the place values. So we've got a 32 plus an 8 plus a 4 plus a 2. So that is 32 plus 8 is 40, 44, 46. So the denary number 46 would be written in binary as 101110. The other thing that we can do is we can do binary addition. So we have some golden rules with binary addition. Our golden rules are 0 plus 0 gives us a 0. 0 plus a 1 gives us 1. 1 plus a 0 always gives us a 1. 1 plus a 1 is 1 0. 1 plus 1 plus 1 is 1 1. Now this is going to come in really important when we start to work out our binary addition. Okay, so let's take a simple one. 1 0 0 plus 1 0. So following our golden rules, 0 plus 0 is a 0. 0 plus 1 is a 1. 1 plus what would essentially be a 0 is 1. So the answer to the sum 100 plus 10 is 110. Now if we want to check that, we can do our place values and work out what the denary equivalent would be. So 1, 2, 4. So our top number is 4, our bottom number is 6. So we are adding together 4 plus 2, don't know where I got 6 from, 4 plus 2, which gives us 6. So if we have a look at this, we've got 1 4, 1 2, that gives us 6. So we know now that that has actually worked. I'll do it again, but without a mistake. 1 1 0 0, so redo that one, plus 1 1 0 1. So we need to think of our golden rules again. 0 plus a 1 is a 1. A 0 plus a 0 is a 0. 1 plus 1 is 1 0. You can see that I've carried the 1 and the zeros come down. 1 plus 1 plus 1 was 1 1. So 1 1. And again, if I wanted to check it, I could do our place values. So our number is 8 plus 4, which is 12, plus 13, which should give us 25. And let's see if this is 25. So we've got a 16 plus an 8 plus a 1, which is 25. Okay, so long as you can remember the golden rules, which I'll do again, that a 0 plus a 0 is equal to 0, a 0 plus a 1 is equal to 1, a 1 plus a 0 is equal to 1, 1 plus 1 is equal to 1, 0, and 1 plus 1 plus 1 is equal to 1, 1. So long as you can remember those rules, you're able to do any size of binary additions. The only thing that you have to be careful of is that the longer the numbers, the more likely you are to make a mistake. So as you go through, just take your time, work at it steadily. 1 plus 1, 1, 0. So 0, 0, there's our 1 can drop down. 1 plus 1 is 1, 0. 1 plus 1 plus 1 is 1, 1. 1 plus 1 is 1, 0. 1 plus 1 plus 1 is 1, 1. 1 plus 1 is 1, 0. 1 plus 1 is 1, 0. So there's the answer to that. Take your time. If you have the opportunity in an exam, go to the back of your answer book and just make sure that you do the denary version and convert the number just to make sure that you've got the correct answer.